Hi, I'm Dave Shook. This is Dan King joining me. Thank you for attending today. I wanted to talk today about a project that Dan has been running at his company for the last few years that I have found I've been lucky enough to participate in, and it to me is a really good example of practical, pragmatic approach to, call it Industry 4.0, call it the industrial Internet of Things, but really transformation of a manufacturing business. And Dan really has been the driving force behind this, the visionary and the guy who's actually sort of making stuff happen. And we wanted to share this with everybody today. So thank you for coming. My name's Dave Shook. I'm with a company called Uptake Technologies. We were the technology partner in this project. And Dan King, Vice President of Davey Textile Solutions, is really the driving force. So Dan, would you please introduce yourself and Davey Textile Solutions?
Sure. Yeah, I'd love to. Thanks, Dave, for having me, and thanks to Litmus for having me here as well. Yeah, my name is Dan King. I'm Vice President of Operations. Background computing science, so I definitely have a little bit of an understanding of this world, but also, of course, textile manufacturing. So I lead the whole aspect of the manufacturing here in the facility. We're in Edmonton, Alberta, Canada, so up in the northwest, and we are, I like to say, we are the textile industry in this city. We're really an oil and gas region, so we have been doing textiles since '86. But in 2000, we needed to pivot because we realized that there's not a lot of people making shirts and pants anymore in the Western region, not anywhere, pretty much in North America. So we needed to pivot. So we moved into safety materials, reflective materials specifically. And Dave will put up some slides that will show that a little more clearly in a few seconds here. But yeah, we started doing that in 2000. In 2010, we realized that the demise of the textile industry was happening across North America, so we needed to get control of the entire vertical. So we started manufacturing. So in 2010 is when we actually decided to buy looms, buy finishing equipment, buy lamination equipment, and doing the whole thing here internally. So we are now have about a 30,000 square foot facility. And that's our facility that does the manufacturing for all global markets. So we're now exporting our products throughout Central and South America, all of the US and Canada. So now we're just looking at other opportunities into other regions. That gives you a little bit of a synopsis, Dave, of what we are up to.
Awesome. So let's talk a little bit about what you do and how you make it. So what we're seeing here is these colored cloth with reflective stripes, and this is what you guys make, right?
Right. Yeah. So we are actually buying the yarn already dyed in that coloration that was required. These follow certain defined safety standards across the world, across the globe. We follow a Canadian standard here for Canadian manufacturers, and then the US standard for US manufacturers, and then whatever appropriate standards are in other regions. And then we're actually partnered with, in this case, 3M, using a 3M retroreflective material and applying that on to the top of that fabric that we've manufactured internally.
Right. Okay. So just to walk through the manufacturing process, you guys receive the thread on these big bobbins. The picture on the left here is the warper, I believe, where the thread is taken off and wound onto these great big drums.
Yeah.
And here we have, another shot of the warper in the background, one of these drums feeding into a loom, but there are also individual threads on the loom for the weft, the thread that goes back and forth.
Yeah. In textiles, we love to have very unique names of everything. So yeah, definitely the as you described it, the weft yarn, the warp yarn. So the warper is the longitudinal direction of fabric. Weft yarn is the widthwise direction. And that's basically displaying all those different yarns all coming together in the, as I like to call it, the ballet of creating that fabric. So
right. And here's the loom itself, where we see threads coming in on the left and fabric leaving on the right.
That's right.
This one is set up to make 4 strips simultaneously.
Yeah, each one of those being about 51 millimeters wide in that case. Yeah.
in that
Oh,
case, right, for that particular SKU.
Yeah.
Right. And this whole green thing here is one loom. This gray box down at the bottom here is, we'll get into that, but that's your data acquisition box, right?
That's right. Yeah. Yeah. So the interesting irony and the reason why we really got involved with Uptake a few years back here is if you look above, Dave, that box just under that right there, that's actually a computer that's supplied with this equipment. Difficulty, like I said, I've got a background in computing, and I went to the manufacturer. I said, okay, I'd like to interface into this digital acquisition box. And they said, you can't do that. It's not designed to have any interfaces to it at all. So we had to go back to square one and redesign data acquisition from the ground up. And that's really what Shook helped us get, or Uptake helped us get to.
Yeah. Cool. Okay. So now we have the cloth coming off of here. Just to give an example, an idea of scale, this weaving room has got, a large number of looms running. Making different SKUs, right? You can see this one here on the left is doing something with orange. The other ones are primarily yellow. How many looms do you have operating in the weaving room?
We're I just got an email prior to coming to the session. We're going to get our 35th very shortly.
Holy smokes.
Yeah.
Yeah.
What you see here is about, I think it's probably 15 or 10 or in that picture, but we have 23 in the existing weaving loom or weaving room, and we've just expanded with another 12 in the other room. Yeah.
Awesome. Okay. Now here in the back, this piece of equipment here, this is the thing that's applying the fire retardant material.
Yeah, the chemistry to it. So what we need to do is we first of all need to remove any lubricants that were required on the yarns to assist in the weaving process. So we wash it back there, and then we apply chemistry to it, depending on the individual needs of the customer. We might put dimensional stability to stop things from shrinking, or we might put UV inhibitors to stop it from fading, things like that. That's what's applied in that machine back there.
Okay. And so here we have cloth coming off of it, and then in the front here we have the laminators. These machines,
that's right. Yeah.
Right? Okay.
Yeah. So that in those situations, what we're doing is we're taking now that reflective material that we buy from some supplier, and we use a thermoplastic adhesive. I sort of compare it to how a glue gun works. So we melt a thermoplastic in behind there, and that then adheses onto the substrate of that fabric.
Okay. And here we have the finished product in nice rolls and applied to, in this case, some fire retardant coveralls.
That's right. Yeah.
Right. Okay, cool. I'm going to turn off screen sharing for a while. We'll come back to it later, I think, as we go into questions a little bit. So feel free, the people attending, please feel free to ask questions. The purpose of this session is really to walk through the experience that Davey had, and to help any manufacturers sort of get an understanding of what they did. So first of all, Dan, can you tell us a bit about like the business environment that you're in, like why you what pushed you to do this sort of project and what you're wanting to achieve as an outcome?
Yeah. So a few years back, well, it was about 2000 when we were exploring this whole project, like I said earlier on. And I was doing at the time what everybody in textiles was doing. How do I manufacture a material in the most cost-effective manner to bring that product to market? So of course, we made our trip to Asia and was looking around to see what we could do in Asia. And it was actually when I was there that I had a realization that really the only advantage I was getting by taking my technology or my manufacturing to Asia was less expensive labor. So falling back on my background in IT, I said, well, geez, if I can find a way of automating this and not relying so much on labor, I should be able to make this a cost-effective solution in North America, which is kind of unheard of in the textile industry. We're still seeing a demise of the textile industry globally, mostly across the Americas. So we said, well, let's figure out how to do this with an automated process. So I actually made a trip to Germany shortly after that to a textile show and worked through how do I, first of all, what equipment do I need? And then secondly, how can I make that equipment more efficient? And that's the call to Uptake in 2018. What can we do to find a way of enhancing the automation on this on this. Some of it is automated, but we needed to get better at that automation process.
Right. That's really interesting. Like the sort of going to China and realizing that, you know, the only advantage there is lower cost of labor. And with like the sort of supply chain disruptions that we've seen in a post-COVID world, right? The low cost is great when the supply chain is reliable and the market is highly predictable, but you give up on a lot of agility when you do that, right? And we're now seeing a lot of companies beginning to like re-onshore production because, you know, the supply chain is no longer, you know, as predictable, and companies are beginning to do that. So it's neat to see, you know, you were quite some distance ahead, but the automation here is really to help you deal with the cost of labor aspect. And you know, that's fun to see. Okay, cool. So for the project that started in 2018, what were you trying to change and why were you trying to change it?
So ultimately, I was trying to figure out a way of, first thing is, I sort of say there's 5 stages to the transition, the automation transition or the IoT transition. One is to digitize. So first thing I needed to do was I needed to get the data from all my different devices. There's no physical data collection on some of those devices at all. And some there's a PLC that's very proprietary and would have been a challenge to interface into. And there are those, like I say, those looms, there is a computer system on there, a digital monitoring system on there that I can't tie into. So ultimately the first stage, and that was our struggle back in 2018, is how do I collect this data? And how do I collect this data in an agnostic manner? So I'm getting the same kind of data from all my devices. I'm not getting one interface that's going to produce, I have to interface into this XYZ PLC system, this SCADA system, whatever it's going to be. So I need to create a device that would be somewhat agnostic, that I can pull that data forward. And I want to do that in a cost-effective manner.
Right. Okay, cool. So that kind of gets into the device itself, right? So this is the data acquisition device that's used to collect data from the looms, right? And this was, you know, custom designed because the looms have got 24-volt systems, and it was necessary to go around the PLCs and actually measure the voltage on the 24-volt sensing lines to detect which, you know, outage was happening. You couldn't, you know, plug in through some you know, standard protocol, you know, PLC communication protocol. You actually had to go right down to the hardware and do that. That raised some, you know, some bumps along the way, right? But can you talk a little bit about that?
Yeah, one of the interesting things, Dave, that you and I discovered together was what I call the observation effect, but I'm sure it's the instrumentation effect actually is what's defined under instrumentation protocols. When we first tied these systems into the device, we actually started changing the behaviors of the devices themselves. So we had to actually explore, and I'm not an instrumentation engineer by any means. So they knew right away that what we were doing was we're feeding current back up the channels and affecting how they behaved. So we had to put optocouplers, optical isolators into the system. That was one of the things we discovered. We needed to use very, very high functioning processors that were readily available. So these are actually enhanced. The ESP32 is they're all enabled Wi-Fi. So I'm transmitting that data up. Now I'm not having to run cables to each one of my systems, you know, a data cable to each one of my systems. I'm just using Wi-Fi to transmit all that data up into the cloud.
Right. Okay, cool. And like this is the other part that's really nice about the communication from my point of view is that the communication uses standard protocols and hits standard cloud level stuff, right? So device agnostic, Wi-Fi, MQTT, up to Azure IoT Hub, which is, you know, really provides you the data into an open data estate. So you're not having to grab data from, you know, a loom vendor's cloud, and then, you know, the finishing machine vendor's cloud and all that kind of thing, you actually have control of the provenance of your data, you know, all the way through, which to me is a big deal.
Yeah, we're using, you can see on the right, Power Apps, Power BI, very, very
Yeah,
available tools. It's and I can bring them up on my cell phone. I can bring them up on, I've got display boards now. I just installed in the front office of our building. So any person who walks into our facility can see at a glance how efficient our loom operations are right now, our weaving operations are right now.
yeah, to me, that's like one of the really cool things about this is because the data is in your environment, your own people, you know, are able to do things like, you know, well, you know, at one point it was, you know, early on when a loom would go down, there was a Power App that would send out a tweet that the loom had gone down and why, right?
Mhm.
And that was basically a no code environment. That was something that people at Davey could do and extend or turn off, as the case may be, right?
Yeah.
And the same with the, you know, the downtime tracker, which is just another Power App. This, you know, this display, initially we had 23 looms, and, you know, your own people can extend this as you go along. You're not like beholden to some external company that's going to charge you, you know, some rate per month to, you know, add stuff. So the reason why I like that is that when you went through this project, there was you know, could you talk to the journey that the people had to go through? Because I think that's actually like the key here, is that you actually helped your people go through the process, and the ability to, you know, tinker with the user experience was a critical part to that.
Yeah, there's two sides to that, really, Dave. When we explore this, number one is it really important to get the feedback from the people about their ideas in actually designing this process. So it's very easy for us, Dave, you and I, to sit here and come up with some monstrous system that's just, you know, bells and whistles all over the place. But frankly, if we're not getting an input from the people who are actually handling the devices or the actual materials, we don't really understand what they need. So
Yeah.
that was one of the key learnings we had too. Like initially it was just we're designing our own systems and rolling it out there. But once we started really understanding their needs, we started really modifying and creating much more effective tools. The other side of it, we always talk about user adoption. That's a very common term that we use, how we're going to get the users to adopt our systems. And I didn't like that mindset. The adoption is sort of almost, to me, had this feeling of ramming something down somebody's throat. And that's really not the mindset I like to have. What I look at is not adoption, but adaptation. How do I create systems and how do I create environments where their users will adapt? So it's a bidirectional kind of relationship. We're going to work with our end users or our customers, if you want to put it that way, in trying to understand what their needs are and deliver that to them. So it's a bidirectional kind of relationship we work with on that side.
Yeah, and that to me is like the word agile is like overused these days, but in my experience with automation in general, there's, you know, a huge component of any automation project is making sure that the fine details of the experience of the person at the sharp end who has to use this thing in order to get their job done, that those fine details are really sort of slugged out in use. You can design it up front, but you really only have, people only understand sort of the blocker that's immediately in front of them. And so when you remove that blocker, you slam into another one immediately after. So any given automation project has to budget time and resources to go, oh, we didn't expect that blocker. Let's, you know, change the color of these blocks, or let's change, you know, the update rate, or whatever it happens to be, something that you did not expect that you were going to encounter. but that really does need to be fixed in order for the application to be accepted by the users. And just the act of engaging the users in that fine tuning can actually increase the acceptance and their willingness to adapt to the user experience.
Yeah.
Right.
Yeah.
Yeah. Really important piece. So did the project succeed from a technical point of view and from a business point of view?
Yeah, I never see this project ending. So phase,
Ah,
I want to call it phase one, is successful. We have display boards up and we're monitoring loom performance. And one of my metrics that I was monitoring is OEE.
right.
It's a modified OEE. I'm looking at for downtime right now or uptime. So when I first monitored, when I first captured the data and really looked at it closely was October 2022. And I saw about March of this year, but a double. I increased my uptime efficiency by about 100%. I grew
Holy
from
smokes.
100% uptime to 60% uptime. Yeah. So just by really focusing on uptime with my looms and people knowing that we were all watching it together, really made everybody focus on, oh, that's the key metric they were watching for.
Right. So that's the old, adage about, you can't manage what you don't measure. Right. And once you can measure it, then you can manage it. And once you start communicating that this is an important metric, people take that on board. Right.
That's right. Yeah.
Yeah,
Now we, like I say, we've just installed a display boards in the front office. So it's even more obvious to our people in the weaving area that people are watching.
That's really cool. Right. And like you can, from a management leadership point of view, you can play that a couple of different ways, right? But in general, it is better to play it so that people can take pride in their contribution to the improvement of the business operations, right? Rather than it being a stick to hit people with, right?
That's right. Yeah.
Yeah. So have there been any like unexpected benefits that showed up in this project? Like, did you get all the benefits you expected? Did anything show up that you weren't expecting to see?
Yeah, like I say, it's a continual voyage. It's a journey we're on, and things keep on arising that we address, which is the unexpected benefits. We work closely, as you know, work closely with an instrumentation engineer as well, and it's kind of interesting how we go through the journey all together and suddenly say, hey, well, what about monitoring temperature on that particular device? What does that show? And then we put a small device, we pilot that device in the system and realize that, oh, our temperatures aren't unified across all bands. That's an interesting observation. So we as you know, Dave, we use Lean Six Sigma methodology here. And that tells us, let's get data, let's look at that data and try to learn from it to make our processes better. And so what now if we're capturing temperature data, for example, suddenly we can modify our process to deal with either fixing that temperature or accommodating that temperature in our process.
That's really interesting. So you get variation. So yeah, so variation in temperature is going to affect things like, ultimately the tension in the material once it's finished, right? Because if you're weaving when it's hotter, the material is tends to expand and is also probably stretchier at higher temperatures. Humidity would have an impact on natural fibers as well.
Yeah, big impact as well. So we're monitoring the humidity, the moisture content in the rooms, moisture content of the materials itself. Because we have to go through a wet dry process, we have to monitor how much moisture is in it after a dry process. Yeah, there's a lot of interesting variables on that. We keep continually working with our instrumentation engineers to figure out how to monitor what, knowing what we can monitor. He's obviously the specialist in sensing systems, and we need to work with him to say, how do I monitor this particular thing? So,
yeah, that's really neat, right? And like the thing that makes this such a great project to me is you're dealing with practical grubby issues of, how do we measure how fast the loom is going? And those are, individually things that you can bang your head on, right? But the payoff in the long run has been really substantial, right? You've been able to double basically the output per loom by just having access to the information about, when they're going down, why they're going down, and changing how you operate the business based on that. And it'll also, you've put this Lean Six Sigma process in place where you're able to make, conduct experiments, look at the results, make decisions based upon the data, and then decide, well, do we want to roll out temperature measurement further? Does it make sense for us to roll out humidity measurement to more than one location, and so on, right? So, it's, as an engineer, it's like, this is what we're supposed to be doing, right?
Yeah, I actually wouldn't mind highlighting one little note too, that
Sure.
one of the little experiments that we ran, and it turned out to be very fruitful, was utilizing a standard computer optical mouse as a measurement device. So we're now monitoring all of our production of our fabric through lamination. That's the one point we're using it mostly. Just using standard, what you would go down the street to Best Buy or wherever you're going to go and buy an optical mouse. So I think we're kind of unique, probably globally, in the use of a mouse for that application.
That's really cool. Yeah, that's great fun, because in this case the mouse is standing still and the surface underneath it is moving, but like the drivers exist. That was a stroke of genius on the part of the guy who came up with that, really.
Yeah, I like for that.
Yeah. Okay, so couple last questions. I think, would you do it again? The answer is clearly yes, but
I haven't stopped doing it, so yes,
you haven't stopped doing it. You're continuing on this journey, right? If you knew when you started what you know now, right, what would you have changed?
Not much. I think we're in the place, and we didn't waste a lot of time getting there. We're in the right place. We all, the whole team, all the different heads involved in the team, all started out the journey in the same place. Let's find an efficient way of creating this solution. We focus on efficiency, cost effectiveness, and we attained that. Raspberry Pi is our recognized device for a lot of our data collection. Arduino technology is what we're using for microprocessors, keeping it really standardized as much as possible. Using standard, like you say, standardized methodologies for data transmission. Let's not get into anything proprietary. We get into proprietary and we get stuck in somebody's channel, and that's what I'm trying to avoid here.
Right. So it's like, so now you did bump your head on a few things. Like, in fairness, the hardware design, there were some issues with the power quality going into those boards, right? And the boards had to be redesigned to cope with poor power quality, right? So you did kind of have to roll with the punches.
Yeah.
Right.
Yeah, that's fine. I mean, that's still because I think we went in with such a cost-effective solution. Having to rework some things, that's fine. And actually, it turns out now that standardized board that we designed right at the outset now gets rolled out across all devices. So it's proving itself to be a very, very effective solution across the board here.
Awesome. Okay. Well, I think we're out of time because Lynn just showed up and we're at 2:45-ish. Thank you very much. I haven't seen any questions in the chat, unless I'm looking at the wrong place. Are there any questions?
I see the chat number going up, but I can't.
All right. No questions.
Vince just asked how long we had pies installed. We've had pies installed. We're using pies for vision capture right now that were installed in late 2021, I believe. They're still operating, and actually rolled that out across the board. We're using, per laminar, we're using 2 pies and they're interfaced together. One's for basically the interface to the mouse system, and one's for vision collection, or data collection from vision systems. And we're also using pies on that finishing range. We have 3 pies and then they communicate with each other to talk about state of the operation in there.
Okay. Cool.
Any issues
Hey.
with SD card? Yes, SD card lifetime. Yes, we we modified them to have drives on them, SD or SSDs. The question on predictive analytics and prescriptive analytics is the next big exploration. That's one of the reasons why we're working with Uptake as well. They have some previous competency in that area, so we're definitely looking at what we can do around predictive and prescriptive analytics. Yeah. Big fan of pies, are you, Vince? One of the things that's of course come to light is Raspberry Pi, the technology, the microprocessors using the Raspberry Pis are becoming less and less available. So sadly, we're having to look at other options there. So we are starting to explore now some Intel technology.
Right. Yeah, I've heard there are supply chain issues now on really like the lower end microprocessors, because they're the lower end chip fab is done in China, and there's beginning to be more issues with chips coming out of China, but the higher end stuff is still largely made in Taiwan and some in North America. So it's actually ironically easier to get your hands on the higher spec sort of 10 nanometer rather than the 100 nanometer stuff.
Yeah. All right. Thank you.
Okay. Thanks, everybody.